I'm Nina, and this is my Lab 5 Makeup Lab. So here is my RC circuit. You can see the power going into the resistor and then being fed into the capacitor, with VCC being read right after that. Then here is my Arduino code. So first here are the constants, where tau, the period, is calculated by R times C, which is the resistance and the capacitance. And then the read interval is just tau divided by 50, which is 2 milliseconds. So starting off with the timing loop, so the current time is read by millis, and then once that interval of the current time minus previous time is greater or equal to the interval, then the time is reassigned, and then the state is toggled on and off, which leads to the capacitor discharging and charging. And then readings are taken every 2 milliseconds here. And then also at the beginning there is a delay of 5,000 milliseconds, which is holding the 0 B for 5 seconds, allowing the capacitor time to discharge. My processing code, starting off by creating a table to save the data in, and then reading in the data. Here's V drawn as blue circle and BC drawn as green, and then these are the boundary conditions. So I added a new function called void key press, and this is just to make it easier to save the data into a CSV file whenever a key is pressed. Then using this for loop to draw these 6 horizontal lines for 0 to 5V. Here is the code for my legend with the text right next to it, and it's shown by ellipses. Right, so here's the RC circuit for the 100K resistor. As you can see, the capacitor is charging and discharging as it toggles on and off. And it's going at a pretty slow rate because of the high time constant, since T is R times C, and then the resistance is pretty high for 100K. This is for the 10K resistor, so the capacitor is still charging and discharging as the switch turns on and off. This time the time constant is a lot lower since the resistance is lower, so it's charging and discharging at a faster rate. And looking at the MATLAB analysis of this, running the MATLAB code. This is for the 10K resistor. You can see it sort of follows a first order system. It's charging and discharging pretty quickly. This could be due to limitations from the power coming and through the resistor. But yeah, it follows the exponential charging and discharging pattern. All right, and then looking at the MATLAB for the first order system, the RC circuit. So yeah, this follows what we would want to see for a first order system, that exponential charging. And then for the 10K resistor, since the time constant is much smaller, it charges much faster compared to the 100K ohm resistor, which takes quite a bit longer. But yeah, they both respond to the step input for this. So this is my thermistor circuit. So you can see from the oscilloscope, if I apply a cold step input, the values increase. This is because the resistance decreases after the thermistor is cooled, so the out increases. And then applying a warm input from my hand, you can see that it decreases. And this is because resistance is greater, and therefore the out decreases. And the resistance is greater when R equals 10K from the data sheet.